Hello dear students, I welcome all the standard 7 students on this online class. So last class we have discussed about that mass, measurement of mass and its unit, and I hope all of you have understood that one, and I hope you all are going through your book also. Today we will be going to discuss about weight and its unit. Okay, so without delaying, let's get started this one. So, what is the meaning of weight? Weight is not the same as mass. Both mass and weight are different physical quantities and both are completely different. So, here we will know about weight. So, the weight of a body is the force by which the earth attracts it towards the center due to the force of gravity. So, what is the meaning of weight? You all know that one earth is having a gravitational force of attraction, because of which each and every object is attracted towards the center of the earth due to gravitational force. Okay? So, if we consider any one object, so the amount of force required by the earth to attract that particular object to its surface, that is called as the weight. So, how much amount of force required by the earth to attract an object towards its center is called its weight. So, by the term force of gravity, we mean that the force which acts on a body and thus enables it to exert an equal force on its support. So, to support that gravitational force of attractions, equal amount of force is required. Okay. So, we all constantly experience the force of gravity, that is the pull of the earth. Each and every object, whatever it may be, which are present on the surface of the earth or above the surface of the earth, is because of the gravitational force of attractions, or each and every object are experienced with the force of gravity. Okay? So, it causes an unsupported body to fall on the ground. So, because of which only if any object is thrown vertically upward directions, after some time again it will come back to the earth's surface. Okay? So, what is weight? What we can define weight? That means weight is nothing but the force which needed by the earth to attract an object. Okay? As the distance between object and the earth increases, the force of gravity between them decreases. If the distance between that object, or if we say that if an object is moving in upward direction, that means the distance between the earth and the object is increases. So, in that case the force of gravity between them decreases. Thus, you would weigh less on the top of a mountain than at sea level, since on a mountain top you are further from the center of the earth. If we are moving in upward directions, at that time our weight will be also decreasing. So, because of that reason only, if we are standing on a mountain top, our weight will be less as compared to when we are sitting or on the surface of the earth. So, the weight of a body varies from one place to another place on the earth. This is because of the shape of the earth and its rotations. Because of its rotations and the shape of the earth, the weight varies from place to place. So, this is because of the shape of the earth and its rotation. The earth is not perfectly spherical, but bulges at the equator like oval shape. If a body is taken from the equator to a pole, its distance from the center of the earth decreases. So, consequently, the gravitational pull on it increases. If the distance between the object and the center of the earth is decreases or less, that means more amount of force will be there, or the weight will be more. And because the earth is not having a perfect spherical shape, it is like the shape of an orange. Okay. So, because of which different parts of the earth are having different types of weight, just slightly different weight we will get. Okay. So, I hope all of you have understood that one. Then the formula for calculating weight. The weight W of an object of mass m can be calculated by using the formula W, that is force of gravity is equal to mass into field strength, or it is called as gravity. That is, W is equal to m into g, mass into gravity, where g is the strength of the earth gravity and its value is taken to be 9.8 Newton per kilogram. So per kilogram, 9.8 Newton amount of force of attraction is done by the earth, or roughly 10 Newton per kilogram. So each and every object, if it is having 1 kilogram, that means the earth required 9.8 Newton amount of force to attract it. So it is commonly called acceleration due to gravity also. That G stand for acceleration due to gravity. Okay. So did you understand this one? The formula for calculating weight, W is equal to m into g, and for each kilogram how much amount of force of attraction is required, or how much amount of force is required by the earth, that is 9.8 Newton per kilogram. Okay. Then the unit of weight is, as weight is a force, its SI unit is also Newton. Force and weight both are having same unit, that is Newton. In the CGS system, it is measured in dyne. 1 Newton is equal to 10 to the power 5 dyne. Okay. Then the gravitational units of weight. Besides dyne and Newton, there are other units to measure weight, that is gram force, GF, and kilogram force, kgf. These are gravitational units of force which purely depends on the value of acceleration due to gravity at a particular place. Okay. Then 1 gram force can be defined as the force acting on a mass of 1 gram. If the force acting on a body of having mass 1 gram held on the surface of the earth, or it is the force with which the earth pulls a mass of 1 gram towards itself. If any force of attraction is occurred or offered by the earth on 1 gram mass, then it is called as 1 gram force. In the similar manner, 1 kilogram force can be defined as the force acting on a mass of 1 kilogram. If the force of attraction offered by the earth on 1 kilogram mass held on the surface of the earth, or it is the force with which the earth pulls a mass of 1 kilogram towards itself, then that is called as 1 kilogram force. And the relation between gravitational units and other unit is equal to, it is given here, you can see that 1 gram force is equal to 980 dyne, and 1 kilogram force is equal to 9.8 Newton. Okay. So up to this much I think all of you have understood. Again, you must go through your book properly. Next class we will discuss about the measurement of the weight. Okay. Thank you.